All right. Good evening, my excellent biology students. Hope you are doing fine, and I hope you had a wonderful day. So, funny thing is, I started talking, but I didn't add myself on this live class. Like, I didn't unmute myself. So, I hope I'm audible. Someone to just let me know if I'm audible. Someone to just let me know if I'm audible before we begin with this live class. So if it is not mungat mumvera venikamba, because I started talking like after the music. So that's when I'm got nikamba and mumvera kansh. I'm talking to myself. Otherwise, I hope I'm audible. I hope I'm audible, and I hope we are all doing fine. Personally, I am tired. Nalema pano, but we just have to do this. We have to do this. Okay, so yeah, you've confirmed that I'm audible. Okay, wonderful. Wonderful. So in this live class, it's just a review of assignment 3, which is based on genetics. Genetics here imabwera every year, whether you like it or not. It is coming even in your paper, the one that you're going to write on the 8th of August. Irimu. So you just have to know it. Funga chemwaizi wa genetics. Otherwise, lipo kale wangu limpo already limpo akamba chani limpo akamba chani limpo. I will just have to see limpo in person, kamkalipire in person. Atine, I've just come here without a link. I'm sure you received the notification, you subscribed to the YouTube channel, so I'm sure if you are a subscriber, I'm sure you always receive a notification. If you haven't yet subscribed to my YouTube channel, then you can't receive the notification. Otherwise, all those that have subscribed to my YouTube channel, just send me a screenshot. I'll buy talk time for you. Just appreciate you. So everyone has confirmed that I'm audible enough. Therefore, I feel we can start with this live class. Therefore, we can start, isn't it? Someone to say yes, sir, we can start. Then I begin. Or maybe we wait for our fellow students to join. We can start. They'll find us. No, we'll make a plan. Limpo. Especially when your results are out, so that we celebrate nicely. Because mnapasa kudale. Okay. I've been told to start. So, as we all know, genetics is simply a study of inheritance. Yeah, genetics is the study of inheritance. It simply looks at how traits are passed on from offsprings from parents to offsprings. So today I had the discussion with my students in class. I was telling them that that it's possible ma blacks babiri bankana na mwana mzungu. It's onshusha and no, it cannot be possible. I'm even telling you, do you know that it is possible? Ma blacks babiri bankana na mwana mzungu. Do you know that it's possible? Do you know? It is very much possible. Two people who are black bankana na mwana mzungu. It is possible, provided that amongst the two parents in their lineage mulikuwa mzungu, then it is possible for them to have a child who is a white person. Very much possible. So genetics looks at how characteristics are passed on from parents to offsprings. The nose that you have, generation to generation, until finally you have it. And you also pass it over to your offsprings, and your offsprings will pass it over to their offsprings, just like that. So genetics looks at how these characteristics or these traits are passed on from a parent to an offspring. Okay, so tichokera patali sisi zamene tili nazo izizachokera patali, and now you have it and you're going to give it to someone else. Your children are going to inherit the features that you have, some of the features that you have. So genetics is an interesting topic. It covers a number of things. Not only does it look at characteristics, but it also talks about diseases, genetic diseases or genetic disorders like hemophilia. Hemophilia it's a genetic disease, meaning it's a disease that you can inherit from your parents. Okay. Red green color blindness, all those are examples of genetic diseases that a child can inherit from the parents. So genetics also looks at that, and you need to know the genotypes of hemophilia. You need to know those genotypes, okay? Because when it comes to cross diagrams that come in paper 2, it's either the questions are going to be based on, genetic diseases, which is hemophilia, red green color blindness, or they can be based on blood group. The questions, the genetic questions, they can be based on blood group. So you need to know the blood groups: blood group A, blood group B, blood group O, blood group AB, and you should also know the the genotypes of these blood groups. Okay, and what else? Again, genetic questions can be based on features like height, skin tone, or maybe if they bring to my plants, they will say, "Oh, this plant is tall, then this other one is short." So you should know what you should expect. Expect such in your exam this year when it comes to genetic questions. Expect such in your exams this year. Otherwise, whether you like it or not, my questions ya genetics yalimu. It's the final question. It's the final question in paper 2 section A. Okay, so always keep that in mind. Yeah. And then the other thing that you need to know, my excellent students, is that paper 1, when it comes to paper 1 is so easy because the topics are there. Like, you can know what is coming, what will be in your paper for paper 1. So all these questions that you're seeing here are coming from past papers. Okay. And when it comes to genetics paper 1, you find that comma 30, 20, 29, 29, 28, those questions are based on genetics. So if you go through past papers and you become familiar with the questions that they bring, it'll be so easy for you to pass paper 1. So what causes people to fail? One of the factors that will cause a student to fail is if they're not familiar with a past paper. You should be going through past papers because they will give you an idea of what you can expect in your exam. So I hope we go through past papers. I hope we do go through past papers, my students. I hope we do that. I hope we do that. Because mwenango na past paper mkaboyo napo. Uyo mushtono iyo kuigwira past paper. Kuyopa kuigwira past paper che, because I know it gives me fever, sir. It gives me fever. Nikaona che past paper ni mayopa mtima umatunda fast. Manje msaka iona msaka ziva bwanje mine vile past paper. That's me on. So I just sort of mentioning that. So when it comes to genetics, things are known. Like you can tell, you can predict what will be there. So I'm telling you what will be there. So just ensure that you familiarize yourself with past papers. They will help you. They will help you. Okay. So I think we can start with the questions. I know for some the questions are not clear. So what you can do is just ensure that as you are watching this live class, make sure that the live class it's clear. Like there are settings that you can set to make this live class to be like clear. You can increase the quality of the video. So do that. Make sure that you do that as you are watching this live class. Okay. So let me now do this. We've got our first question here. Okay, so question 1, I hope you can see the question. Question 1 reads, the number of chromosomes in a gorilla chick cell is 48. How many chromosomes will its ovum have? The number of chromosomes in a gorilla chick cell is 48. How many chromosomes will each ovum have? We've got A 96, B 48, C 23, D 24. What is the answer, my excellent students? Limpo is celebrating, power is back. Violet, you're late. Yes, Violet, you are late. Karen is saying, yes, it's possible. My uncle has a child who is white, but they are both black. My own statement, yeah, proof. Muma shusha gaidi. No, but how? It's very possible. She has even said her uncle is black. Even the wife is black. But their child is white. You see? Very much possible. So even to visas, not even as kuda busan. Okay, because you find that even some couples they even divorce. When a child divorce at no, it's not possible. How you're even questioning your wife? But it's understandable, especially if ngati simuiziva genetics munaipunzirepo. You may suspect your wife. You may be like, how? Iwe. Ungankaina mwana mzungu, but how? You get. Otherwise, it's very possible. So, what's the answer for question 1? What's the answer for question 1? Okay, I can now see the answers. So how many? Okay, C D. Okay, so question 1, the answers I'm seeing: Karen, D. More comment mbili kanshi. Got D from Go. Okay, another D from Miss Helen. D, Viana, Evelyn. D. Wonderful, Mr. Innocent. D. Okay. Patience. D. Okay. Dimpo. D. Okay. Annie. D. Euphemia. D. Fallacy. D. Risbel. D. Audrey. D. Agnes. D. All right. So yeah, let's read the question. So the number of chromosomes in a gorilla chick cell is 48. So this chick cell, which has got 48 chromosomes, it's a somatic cell. It's a body cell. So as we all know, a body cell or a somatic cell, it has got diploid number. Okay, it has got diploid number. It has got diploid number. So diploid number, it is the full number of chromosomes. Okay, diploid number, it is the full number of chromosomes, of which when it comes to animals like human beings, the diploid number for human beings it's 46. Okay, so meaning the body cells or somatic cells that we have, they contain 46 chromosomes. That's the diploid number. But in this question, they are saying that the gorilla chick cell, which is a monoploid, which is a somatic cell, it has got 48 chromosomes. So meaning 48 is the diploid number. Okay, so since a body cell of the gorilla chick has got 48 chromosomes, then wow, how many chromosomes will be in an ovum? So the ovum is a gamete. An ovum is a gamete. It's a sex cell. And since it's a gamete, it has got half the number of chromosomes of that of a somatic cell. So since the somatic cell in this case has got 48, half of 48 is 24. So the answer for question 1 is D. Okay, that's the answer for question 1. Okay. So just a minute, my students. Okay. So I'm seeing a question. It's Violet. Yes. So this is assignment 3. We are answering assignment 3, okay, which was given last week for genetics. I know that we never went through it, so that's why I thought of going through it with everyone. So it's actually assignment 3 for last week. Okay. So another question that I'm seeing, sir, is it possible to be hypersensitive, hypertensive, hypertensive? Mm, what's the question? Just a minute. Is it, sir, is it possible? There's a student who is having issues with joining, and they're the ones they are texting me, so I'm trying to help them. Let me just send them a link and then I'll respond. Okay, I've sent a link. So, sir, is it possible to be hypertensive if you have the same genes with your mom? Ah, hypertensive, it's not necessarily a genetic disease. So I cannot say because you've got the same genes with your mom you can have it. No, I don't think so. I don't think so. Because one, it may have this. There are some components of genetic in the condition, but I don't think it's solely a genetic disease. It's not. Okay, so it's not caused. It's not brought about as a result of maybe you inheriting uh genes from your mom. No, no, I don't think so. Yeah, I don't know if I've answered your question. Okay. Sorry, so I think there was a mistake when I was typing. It's supposed to be assignment 3 because genetics was assignment 3, so it was just an error. Yeah, otherwise this is assignment 3, not assignment 2. Yeah. So I think we can move on to the second question. So which of the following is an example of discontinuous variation? Which of the following is an example of discontinuous variation? So we've got A, height range in a class from 120 centimeters to 155 centimeters. B, a family of six boys, I think this was supposed to be 6 boys at 6 boys. Ah, a family of 6 boys and 4 girls. And then C, body weight ranging from 50 kg to 80 kg. And then D, skin color in a community. So which of the following is an example of discontinuous variation? What do you think is the answer for question 2, my students? What's the answer for question 2? What is the answer for question 2? Limpo ati ma sex boys ni ati napanga tabe mistake Limpo. Ifuni konkala a family of 6 boys and 4 girls, not sex boys. So which of the following is an example of discontinuous variation? So I hope we know what discontinuous variation is and what continuous variation is. So there are 2 types of variations. By the way, variations, these are just differences amongst living organisms of the same species. Okay, so if you look at living organisms, we are different even though we are of the same species. I'm a human being, you are also a human being, but we are different. I've got a different skin tone from yours. The size of my eyes is different from the size of your eyes. I've got big eyes. My height is different from your height. You understand? So, in as much as we are all human beings, we are different. Okay, so the differences amongst us are referred to as variations. So, variations are the differences amongst living organisms of the same species. Now, the differences are categorized into 2. So there are differences that are referred to as continuous variation, and then there are other differences which are referred to as discontinuous variation. So when it comes to continuous variation, these are just differences that cannot be clearly seen. You cannot clearly see the difference. It's there, but you can't clearly see it. That's continuous variation. The difference is there, but you can't clearly see it. That's continuous variation. But when it comes to discontinuous variation, these differences are clearly seen. Like you can see that, oh, this is this, this is that, this is red, this is black. You can clearly see the difference. That is discontinuous variation. So yeah, having defined the 2 types of variation, which of the following is an example of discontinuous variation? So we've got height range in a class from 120 centimeters to 155. Then B, a family of 6 boys, not 6, a family of 6 boys and 4 girls. Then C, body weight ranging from 50 kg to 80 kg. Then D, skin color in a community. So most of us are saying D. Okay. Anyone with a different answer? So can someone explain why you are saying D? If you are saying D, you should be able to explain why you're saying D. Why are you saying D? Someone to give us like a brief explanation. Mwachinja answer. Yeah. Mwachinja answer ka. So small on is continuous variation, discontinuous variation. Why? Why D? Why mwezo sanga D? Why mwezo sanga D? So yeah, the answer is actually B, not D, not your D mwezo kamba. When it comes to skin tone, my students, I mean, yeah, we can get a light person and a black person and we can clearly see the difference, right? But if we get the darkest person in the world and we get another person who is dark, when we put them together, the difference is there. They're both dark. But the difference is there. You just can't clearly see it. Tikatenga muzungu na muzungu tawafaka pamoja. Difference ilipo, but you just can't clearly see it. It's there, but you can't clearly see it. That's the point. The difference is there. It exists, but you just can't clearly see it. Okay? But when it comes to sex, for example, like a family of 6 boys and 6 girls, I mean 4 girls, you can clearly see mafaka pamoja umatenga wamuna mkafaka pamoja, you can clearly see to say uyu ni mamuna uyu ni mkazi. The difference is clearly seen. That's discontinuous. So yamene mwanzo kamba dini achani mwanponya mtima mwando kamba dishu, it was a mistake. Okay. Must then apologize. Question 3. A couple has 3 successive daughters. What is the chance that the 4th child also be a girl? It's a trick. A couple has 3 successive daughters. What is the chance that the 4th child also be a girl? A, 25, B, 50, C, 75, D, 100. What's the answer? Confused, so odd. So double nanga mubwera mubwanji ma percentage natawa ku maths. Ma percentage menene natawa ku maths bayaleta ku biology. Ni chani aba bantu? Yalimo na ma percentage. Stand calculate. That's the percentage. What's the percentage? Okay. So yeah, the answer is B, 50%. Because every time you are expecting a child, there's a 50-50 thing. It's a 50-50 thing. It's either you're going to have a boy child or a girl child. It's a 50-50 thing. Every time, a 50-50 thing. Even though you had 3 daughters, the next time you'll be pregnant, there's a 50-50 chance. It's either it's a boy or a girl. Never 25 chance. Never 75. Never 100. It's always 50-50. It's either a boy or a child. So it's a 50-50 thing. So the percentage is what? 50. What is the chance? 50% chance. Okay. So the answer is B for question 3. We can move on to question 4. So question 4 reads, units of inheritance affecting the same character of trait and located on the same position in homologous chromosomes are called what? A, alleles, B, genes, C, chromatides, D, loci. What's the answer for question 4? What's the answer for number 4? Units of inheritance affecting the same character or trait and located on the same position in homologous chromosomes are called A. alleles, B. genes, C. chromatides, D. loci. So bafunza apa ati ka unit of inheritance kamene kamachita affect character or characteristic or trait. Kama pali trait we mean skin tone, height, the features that we have, those are traits. So they are saying a unit of inheritance which affects, meaning it determines, isn't it? It affects those things like height, skin tone, okay? And this same unit, it is located, there are two actually, they are located on the same position, okay, in homologous chromosomes. They are on the same position but on different chromosomes. That's what they mean when they say homologous chromosomes. They are just two chromosomes which are the same, but they've got the same design in terms of where the genes are located. They are located on the same position. So if I try to draw, let's say we've got a gene like that. Got a gene like that. Now, this is a gene. I mean, it's a chromosome. And then on this chromosome, we've got genes on it. Per surface, so it can be here, per position per gene, not per position per gene. On the same position, right? But on different chromosomes. These two genes, one is from the father, the other one is from the mother. They are controlling the same thing. They are controlling the same trait or characteristic, but they're just located on different chromosomes. But they're on the same position on those two different chromosomes. So these are called what? And like you've said, the answer is B. They are genes. I was even saying it as I was explaining. So the answer for question 4 is B. Okay. B. All right, let's look at question 5. An adopted child of blood group O has located the biological father and discovered that he has blood type B. Let me read that again. An adopted child of blood group O has located the biological father and discovered that he has blood type B. Which blood type could not be a possible blood type of the mother? We've got A, B, C, AB, D, O. What's the answer for question 5? What is the answer for question 5? What is the answer for question 5? Mm-hmm. Answer for question 5? My answer is Lekobwera. What's the answer for question 5? So they're saying that an adopted child, okay, of blood group O has located the biological father and discovered that he has blood type B. Which blood type could not be a possible blood type of the mother? Okay. Okay. So yeah, like you have said, when I go pena wali kutamba, I don't know, but like you have said, the answer for question 5 is actually C. Okay, the answer for question 5 is actually C. So there are some who are behind with the video. So if you check that, if you've noticed that you are behind, what you can do is when you tap on the screen, kachan line carried, just drag it until the far end. You'll be up to date with the live class, because sometimes it must adila by YouTube. Okay. So yeah, the answer for question 5 is C. A blood type which cannot be a possible blood type of the mother is AB, because if the mother is AB and the father is B, there's no way that they can have a child who is blood group O. So the mother cannot be AB. That cannot be her blood group. So the answer for question 5 is C. Okay, so the answer for question 5 is C. Let's quickly move on to question 6, my students, before we conclude. The phenotypic result of a genetic cross is in plants are shown in the pie chart below. The phenotypic results of a genetic cross in plants are shown in the pie chart below. So this is the pie chart that we have. As you can see, we've got dwarf, and then there's an angle there which is 90 degrees, and then the remaining part is tall. Which of the following genotypic crosses would produce the above results? So those are the options. What do you think is the answer for question 6? Which of the following genotypic crosses would produce the above results? Ha! Miss Helen, you've made me feel nice, because I really thought that this was going to be challenging for most students. But you giving me that answer, I'm feeling nice right now. What is the answer for question 6? What is the answer for question 6? So for question 6, let me explain, because only one has given us an answer. Okay, there's another one, there's another answer. You really have to think here. Check. We've been given an angle which is 90 degrees. And that angle is for dwarf, right? And the rest of the circle, it is tall, isn't it? Now, we need to know that the whole circle is what? 360. 360, the whole circle. The circumference is 360. And 90 goes into 360 4 times. So if we have 90 already, meaning we are remaining with other 3 90s. Okay? So there's that 90, and then there's the 270. There's that 90, and then the tallness, it is amounting up to 270. The angle for tallness. Let me do this. So if we are to finish up this whole thing, this angle here, it is mounting up to 270. So since there's a 90 and there's a 270, what we need to do is this. We're going to say, okay, what does this mean? 90 into 360 goes there how many times? 4 times. And there's already a 90. So there's a 90 for dwarf. Okay. Let me change the color. And then since we're saying that 90 goes into 360 4 times, meaning we're remaining with 390s, isn't it? So there's 90 for a dwarf and then 90 for tallness, which are 3. I hope we're following. So there's this 90 for dwarf, 90 for tallness, 90 for tallness, 90 for tallness. So ma 90 ya tallness ni atatu, 90 ya dwarf ni mozi. Ndemwe amene vilili hapa, but sana vishowing so there's 90 for dwarf, 90 for tallness, 90 for tallness, 90 for tallness. So here, these are the results. Now, looking at the options that we have, which of the genotypes can bring about such results? It is actually C. Because if you cross C, you're going to notice that for tallness, we're going to have 3 offsprings that are going to be tall and 1 offspring that is going to be short. And that's what we have here. The red one, it's for dwarf, isn't it? The red one, it is for dwarf. The green ones are for tallness. So the tallness, the 3 are for tallness, meaning we've got 3 for tall, 1 for dwarf. And the only option that can produce such results is C. If you do a cross diagram, make a quick cross diagram. So the answer for question 6 is C. I hope I've made myself clear. If not, feel free to ask. Yeah. Question 7 reads, following are some of the details on John's medical report. We've got blood group O, okay, blood group O, that which is 1, and then question 2, so option, so we've got 1 blood group O, 2 height, which is 1.63 meters, and then 3 weight, which is 81 kg, and then 4 sex, which is male. So those are the details on John's medical report. So on John's medical report, it is showing that the blood group he has is blood group O. His height is 1.6 meters, 68 meters. His weight it is 81 kg, and his gender it is male. What type of variation match with these details? What do you think is the answer for question 7? What type of variation match with these details? We've got A, B, C, and D. What do you think is the answer for question 7? Wonderful, wonderful, wonderful. So Miss Hayden actually did a cross diagram when answering question 6. Yeah, even that can help you. You can draw a cross diagram to find your answer for question 6. So yeah, if you look at the options that we have here, they are telling us to say what type of variation match with these details. And I know we know what continuous variation is, and I'm sure we know what discontinuous variation is. So if you look at B, the one which you are suggesting, 1 and 2, what is 1 and 2? One is blood group, okay? And then B, it is saying, so option B, it is saying for continuous variation, it is 2 and 3, okay? And then for discontinuous, it is 1 and 4. So 2, it is height, 3, it is weight, okay, which can fall under continuous variation, yes? And then 1, it is blood group, and then 4, it is sex, yeah, which can fall under discontinuous variation. So yeah, you're correct. The answer for question 7, it is actually B. That's the answer for question 7. Wonderful, wonderful. Let's look at question 8. Which of the following genetic disorders is an example of chromosome mutation? which of the following genetic disorders is an example of chromosome mutation? We've got A, albinism, B, color blindness, C, Down's syndrome, D, sickle cell anemia. Which of the following genetic disorders is an example of chromosome mutation? A, albinism, B, color blindness, C, Down syndrome, D, sickle cell anemia. Okay, this one is interesting because I'm receiving different answers. Okay. So let me first explain something on mutation and then we can continue. So mutation, what is mutation? Mutation is simply a spontaneous change in the structure of a gene or number of chromosomes. Mutation is a spontaneous change, okay, in the structure of a gene or number of chromosomes. Now, we've got two types of mutation. We've got gene mutation or chromosome mutation. Okay, gene or chromosome mutation. When we talk of gene, we're now going. If we're talking about gene mutation, we're now talking about the change in the structure of a gene. So, if it comes to chromosome mutation, we're talking about the number of chromosomes changing. For a gene, it is the structure which is changing. For chromosomes, it is the number of chromosomes which are changing. So there's a spontaneous change in the structure of a gene or number of chromosomes. I hope we are following. So gene mutation is the spontaneous change in the structure of a gene. Okay, and examples of gene mutation, like in human beings, we have albinism, sickle cell anemia, red-green color blindness, and hemophilia. Those are examples of gene mutation. Okay, and then chromosome mutation. Chromosome mutation, it is the spontaneous change in the number of chromosomes. And an example of chromosome mutation is Down's syndrome. Okay, Down's syndrome. My Peter, Down's syndrome. We also have the other one. So there's Down's syndrome, which is the main one. It is the main genetic disorder for chromosome mutation. So albinism, color blindness, sickle cell anemia, they fall under gene mutation. And then in Down syndrome, it falls under chromosome mutation. So the question is, which of the following genetic disorders is an example of chromosome mutation? Yeah, definitely. The answer is C. Someone is saying, I love you. I love you too. All right. Maona ine muntu anuuzako banikonda manje wene limpo simumakambako nokambako. All right. So we can now look at question 9, right? We can now look at question 9. Isn't it? Are we okay with question 8? Are we clear on question 8? Are we clear on question 8? Are we clear on question 8? We are clear on question 8. Dimple, this is when you want to say it. At we love you with the love of God, sir. Yeah. All right. So we can move on. I hope we're clear with question 8. So, Violet, the answer for question 8 is C. C. And then question 9. We can now move on to question 9. I'm looking for the diagram for question 9. I can't find it. Oh, it's down here. Okay. So, the diagram below shows the inheritance of albinism in a family. The diagram below shows the inheritance of albinism in a family. The diagram below shows the inheritance of albinism in a family. Albinism is caused by a recessive allele. Albinism is caused by a recessive allele. Rosemond, you are the one that loves me more. Because you've said it. So, let's look at the diagram. We've got 1 and 2, okay? And then we've got offsprings there. I'm sure you can see there's even a key that has been given. So on the key, an empty box, it is albino male. And then a shaded box, it is normal male. Then a round shaded circle. A round shaded, yeah, a shaded circle, it is normal female, and an empty circle, it is albino female. That's what we have. And then the question is, what are the genotypes of parents 1 and 2? What are the genotypes of parents 1 and 2? What are the genotypes of the parents 1 and 2? Current watch debut. This was a tricky one, eh? My answers. My PC is now almost going off. No one. So Miss Helen has given us an answer. Miss Karen. Okay. So the answer, yes, it's C. So what you need to know is that capital letter stands for normal, and then small letter stands for sick. Capital letter stands for normal, small letter sick. So if we look at what we have, the 2 parents are normal, but they still ended up having 2 children who are what? Who are sick, because there's this box for an albino male who is sick, then there's this circle for an albino female who is also sick, and then there's this shaded box of a normal male. So they had 2 offsprings that were sick of the disease, meaning they have an allele for the disease. Therefore, both parents actually have an allele for the disease. Therefore, the answer is C, because it is the one which is in line. It is the one which is in line with what we have there. So it cannot be B. Why? Because if you look at the first parent, which is capital letter A, When you do the crossing, there's no way that they can have a child who is sick. So for them to have an offspring who is sick, it simply means they both have an allele for sickness. That is why the answer becomes C. Both parents have got an allele for sickness, which is small letter A. Okay, and then they are normal because capital letter A is the one which is dominant for normal. That is why it is a capital letter. So they are both normal, but because they've got an allele, which is a small letter for sickness, it makes it possible for them to have a child or children that are sick of the disease. So the answer for question 9, it is C. Okay, that's the answer for question 9. Then let's look at the final question. My students, let's look at the final question. Malavia Paka mu comment section. So a pure breeding white mouse was crossed with a pure breeding black mouse. All their offspring were black. A pure breeding white mouse was crossed with a pure breeding black mouse. All their offspring were black. Then one of the offspring was bred with a pure breeding white mouse. They produced 10 baby mice. What are the most likely colors of these mice? We've got A, 5 black and 5 white, B, 8 white and 2 black, C, 10 black, D, 10 white. What's the answer? What is the answer? I read the question again. A pure breeding white mouse was crossed with a pure breeding black mouse. All their offsprings were black, meaning black is dominant over white. Then one of the offspring was bred with the pure breeding white mouse. They produced 10 baby mice. What are the most likely colors of these mice? That's the question. There are interesting answers here. So I want you to follow. I don't know how I can explain this on this screen, but let me just say that the answer is A. Okay, the answer is A, but I will try by all means to explain why the answer is A. So we have, I think I will need to draw a genetic diagram for you to understand. So after the live class, I'm going to send a short video explaining why the answer is A. Because like this, I don't think you can understand. Otherwise, the answer, my students, the answer for question 10 is A. So I will send a short video explaining why I'm saying the answer is A. Yeah. So yeah. Someone is saying 20. Good. So the answer, my students, it is A. Oh, Josephine. It's actually 10. Valemba 20. I was thinking Nkulema. ene pano nalema. So I'll send a short video showing you why the answer is A, but the answer is A. So we can end here for now, my students. We can end here. I don't know if there are questions, but we can end here for tonight. We shall continue tomorrow. Good night. Love you too. Manuzat, don't go. Okay, I'm still here. I'm still here. Question 6. Let me go back to question 6. So, I'm still here, Rose. I'm still here. So, question 6. Question 6 is saying the phenotypic results of a genetic cross in plants are shown in the pie chart below. So, this is the pie chart. We've got 90 there, which is for dwarf, and this is a circle. So, if we remove the 90, we're going to remain with 270, right? And then we're going to ask ourselves, okay, in 270, mulima 90 angati, of which the answer is 3. So meaning for tallness, ma 90 ni 3. Okay? And then for dwarf, ni mos chabe 90. I hope you're following. So since that's the case, it simply means if we are to draw a genetic diagram, we should have 3 that are tall, 1 that is short. So what you can do is you can quickly draw a genetic diagram for A, for option A, for option B, and for option C, and for option D. And amongst the answers that you're going to find, look at the one which is going to give you 3 tall offsprings and 1 dwarf offspring. Then that will be your answer. Using the same options, when you get T, I am my options linearly. When you get them and you draw the genetic diagrams, look for the one which is going to give you 3 tall offsprings and 1 dwarf offspring. And that will be your answer. And that is C. C, it is the one which is giving us that answer, where 3 are tall, 1 is short. All right. Good night, Karen, my joy maker. I'm glad. Yeah, my students were going to continue tomorrow. Rose, I'm still here. She said that I shouldn't go. So I'm still here. I don't know if you have a question for me. Okay. Good night. I will shut down the street light. All right, Rose. Okay. All right. We can call it a day. Have a good night, my excellent biology students.